This tutorial is for a stem for a bicycle. The stem consists of two clamping areas. This sleeve clamps onto the steering tube, which attaches to the forks on the front of the bike. This area here clamps onto the handlebars. The clamp for the handlebars is actually a separate piece, whereas the clamp that clamps onto the steering tube is simply a split flange that tightens when a bolt is passed through it. This stem is designed to accommodate a 1-inch diameter handlebar and a 1-inch diameter steering tube. If we take a look at how this is constructed, most of the features are pretty straightforward. The main arm, which is often generically known as the stem, even though that's what the entire part is called, is simply a revolve. The same goes for the clamp for the steering tube. Then we have this flange, which is used for tightening the clamp. This is a body that's been added on that is a revolve and then excess trimmed away so that the sides are parallel to each other. In the handlebar area, we have this widened body here, which is made by adding some material first that is in the shape of the clamp when seen from the end, and then using a revolve cut, we're going to get this resulting shape that we see here by scooping out a revolve that includes this radiused portion. I'll just run back through these really quick to show all that. The first step is just a block for the handlebar clamp. Cut away the excess material we don't want, giving us a shape like this. I'm going to add the arm, which is a revolve. I'm going to add a hole for the handlebar. Then we're going to split this portion off from this portion to create a separate clamp. Going to reduce some of the weight by taking the middle out of the clamp. And then this is that rotary cut I was talking about, a revolve cut. It gives this shape here. We add the sleeve, revolve this flange, cut away the excess, combine it in with the rest, add a hole for the steering tube, cut a slot, add some fillets where necessary. We're going to add some areas, we call this a spot face. This will give a flat face for the screws that will sit here. Then we're going to add all of the holes, and we're going to use a new feature that we haven't used before called the hole wizard to add our holes. And then finally some finishing fillets to complete this. Looking at the starter file, on the front plane we can see the side view. This is the handlebar clamp area, the sleeve for the steering tube. From the top view we can see the hole for the steering tube, the flange for the clamp. See that little radius that we're going to revolve later on to create a cut. And then on the end face here we have the shape of the handlebar clamp and the location of the 4 screw holes. So let's just take our model, roll it to the beginning, take a look at step 1, the handlebar clamp. This is done, so we'll now roll in front of that. So that's done by copying these lines. We'll notice that this is supposed to have a curve to it, but this curve actually is just a result of the revolved cut that we are going to do later on. So what we are going to do when we make this section, we're actually going to make it oversized so that this material in this area can be cut away with revolved cut. So all we are doing, I'll take a look at this sketch, is copying this line, this line, this line, here and here, and then this line should be well outboard of the main clamp area. In fact, you can make this line coincident with this point, which is a tangent of this radius, in the top view. Then what we do is we modify this shape by cutting away all this excess material. So in step 2, we are copying from the handlebar clamp section sketch, layout sketch, these outer lines, and when we do our cut, we use the flip side to cut option, which is going to cut the material out to the outside of the clamp, leaving us with this resulting shape in this view and this resulting shape in this view. The arm is nothing more than a revolve, copying this line from the top layout sketch, this line also. This line goes to the center of what will eventually be the clamp hole. And then this line is an extra line that we add going back to this line. We then revolve this around this line here. So far all of these are merged together. Next step is to add that hole going through the handlebar. This is simply copied from the hole in our side layout sketch. We want to go through all in both directions. Then we're going to split this off, and to do that, the way I've done this is just drawn a single line passing through the center of the hole, and when making the cut, I used the thin feature mid-plane option and made this cut 2 millimeters wide, and this goes through all in both directions. When you complete this, it's going to ask you if you want to keep all of the bodies, and you want to say OK. Check all bodies and say OK, and it'll keep this portion and this piece, which is now floating in space. So now we have the arm and the clamp portion that's going to hold the handlebar. This gives us steps 1 through 5. Step 6 is to cut this slot out of the middle. Again, this is copying the appropriate lines out of the handlebar cross-section layout and doing that on this handlebar clamp center plane, and then we're going to do a through-all cut going in this direction. So that leaves us with this rectangular hole. These 4 protrusions at the end of the arm are often called screw bosses because these structures are what the screws that hold the clamp down are going to thread into. Step 7 is going to be a revolve cut, which is going to give us a nice finished look to the ends of the bosses here. We're going to be doing that by simply taking the top layout sketch and copying this radius and adding a few more lines to it and revolving it around a center line. If we look at the side layout sketch, this was drawn with a simple arc with a 15 millimeter dimension going to the center of the hole. This was just a guess as to what the final shape of the screw boss area was going to look like after this revolve cut was made. In fact, you see it's not a simple arc, it sort of arcs here and then arcs backwards again out at the corners. So making a sketch on our horizontal center plane, and showing our top center layout sketch, what we want to do is copy this line and this arc and draw a center line. I'll just actually draw a line here, and a line here, and a line out here at some arbitrary spot. And then what I'm going to do is drag this arc out a little bit wider and trim away the excess. Now when I go to make my revolve cut, what I find is that even though I made the arc come to the outside further than the width of the body, it still was not cutting away the corners of the screw bosses here. That is because the distance of the screw bosses to the center is greater than the distance from the center to the sides here. So what we have to do is just simply go back into the sketch and make this wide enough so that it's going to cut into this portion of the screw bosses. So you can do this graphically as I'm doing here and looking, or I found experimentally the dimension that seems to work okay is to make that a total width of about 60 millimeters. That will guarantee that this whole area is properly cut away. Step 8 is to extrude the sleeve that the steering tube passes through. This is simply copied from the top view sketch, and the extrude is up to vertex in both directions, going to this vertex and this vertex in the side view sketch. The side view sketch is actually on the front plane, incidentally. Now we have this area. It's going to be this revolved clamp flange. What we're going to do is copy these elements from the side layout sketch, draw a line here and a line here. We're going to revolve this around an axis that passes through the center of this cylinder. So we're just going to go ahead and draw a line that goes through that axis and revolve it around that line. And when we do, we want to leave merge result unchecked, and we want to revolve to go in two directions. So we're going to go one way and the other way, and we're going to go about 45 degrees in both ways. What we're trying to do is go further than the width of our eventual flange. Now by leaving it unmerged to the main body here, it makes it a little easier for us to trim away the excess without messing up this area here. So now all we have to do is draw a sketch which copies these lines from our top layout, and I've drawn a line passing through the center of the circle here and stretched these lines out to it to create a rectangular region. And what we're going to do is cut to the outside and only cut this body so that we're going to get rid of this wedge here and get rid of this wedge here. So let's take a look at that. So here we see flip side to cut. This is drawn down on the top sketch plane and just going upward through all. These are two separate bodies at the moment. Now what we want to do is use the combine command to combine this body with this body. Remember, the combine command can be found under Insert, Features, Combine. We want to use the Add option, and we're going to select this body and this body to add together. Now we can finally add this hole going through the sleeve. Step 13 is cut the slot in the flanges. I'm going to copy this line from the top layout sketch, or we can just draw a line from the center here going horizontal. And the option we are going to make as through all, mid-plane option 2 millimeters wide. So that was just drawn on the top face here and just cutting down. Now we're going back to the clamp area. We've got basically everything done. The last things to add are some fillets, and then finally we can start adding some holes. I'm going to add a fillet here to blend this portion of the clamp into this portion. You see when we do that, we get sort of like a sharp raised edge here, which is undesirable. So we're going to go back and remove that sharp edge. I'm going to do that just by drawing a sketch on this face. I'm going to copy this tangent edge, and make this line and this line collinear with the edges that were already there. That's drawn on, sketch is drawn on this face, and then we're going to extrude through all in this direction. Now we see that we've gotten rid of that sharp little edge. This is now a square edge rather than a raised burr like it was before. Now we can finally start adding the round flat area that the screw heads are going to be sitting in these 4 locations. This is done by copying these 4 circles from the handlebar clamp cross-section sketch. Circle here, here, and here are copied using convert entities. What that does, and again, we are sketching on this face and doing an extruded cut through all in this direction. What that does is leaves us a circular flat area that a screw head will be able to sit on. We now have everything we need, and the last few steps are to add the appropriate holes to our stem and a few finishing fillets. To do this, we are going to use the hole wizard. And the first 2 holes we're going to add are the hole that goes through the clamp and a threaded hole that passes through the body of the arm. So a screw will pass through this hole without threading into it, but will thread into this hole, and when it's tightened down, it'll tighten the clamp against the handlebar. Now, an interesting feature of holes added by the hole wizard is you can add a feature called a cosmetic thread. What it does is adds a visual feature that makes it look like a threaded hole, even though there are no actual threads cut into the material. So let's go back and take a look at how this is going to be done. These 4 holes are designed to accommodate an M5 screw. So this hole needs to be a clearance hole for the screw to pass through. So we want to make it a little bit bigger than M5, perhaps an M5.5 millimeter diameter. And this thread is for the actual screw to thread into. So this would be an M5 by 0.8. What we call this is a tapped hole. When we cut threads into a hole, the term is that we are tapping the hole. So let's go back and just roll this back, take a look at this. I'm going to turn my sketches back on. And I'm going to pre-select a face that I want my holes to be located on. Then I'm going to check Hole Wizard. I'm going to select the type of hole that I want. So for these 4 holes, I first want to start out with just a normal through hole, nothing special about it. So that's the symbol here. I want ANSI metric. The size I want is 5.5. If I go to this pull down, it gives me a whole series of hole sizes incremented by 0.1 millimeters. I've decided 5.5 is about right for an M5 screw to pass through. I want to make this a through all hole. And the body I want the hole to go into will be this body here. Now I want to tell it the position of all the holes. Where I first selected the plane, before selecting Hole Wizard, will crudely drop the first hole in that particular location. I go to my Positions tab, and it will give me a new hole every place I have a sketch point. This is where I first selected the plane, so I dropped a sketch point here. So I'm going to drop another sketch point here, here, and here. I'm going to hit Escape to get out of this mode. I'm going to look straight at this view. What I want to do is make this sketch point coincident to the center of these holes in my layout sketch. So pre-selecting with my Control key, I will select this point and this center point, which is where I want this hole to really go. Make that coincident. I'll select this center in my layout sketch and this point, make them coincident. This point and this point, make them coincident. And this point and this point, make them coincident. Now you can see I've got holes that are going to get bored through that are centered on these little, what I call hole bosses. We just click on the check mark, and we have a hole passing through this body, but not through any of the others. Now we want to add the threaded holes onto this face. So we will pre-select this surface, Hole Wizard. This time we want to add not a regular through hole, but a straight tap hole. So we have this symbol here with a hole with little dotted lines around it. This is a symbol for a hole with threads tapped into it. Click on that one. This gives me options for different types of tapped or threaded holes. The size one is an M5 by 0.8. Again, the pull down gives me all kinds of different size of threaded holes. I'm going to make this a hole that I want to go through this boss completely. So I'll make it about 25 millimeters deep, and I want the threads of the hole to go at least 15 millimeters into the body. So a lot of times you might have a hole that goes further than the actual threaded portion. This is the length of the hole. This is the portion of the hole that has threads added to it. So once again, wherever I crudely picked my plane, make sure you pick this plane, by the way, not out here. Wherever I crudely pick that, that's going to locate the first hole. So I go to my Positions tab, and I'm going to click here, here, and here for my other three holes. I'm going to turn my sketches back on again. I'm going to hit Escape so I can get back my normal cursor, and I'm going to make this point and this point coincident, holding my Control key down. This point and this point. So I'm using the center of my layout sketch. So you see these holes passing through. Hit the green check mark. Let's hide everything. And at the moment we don't see the threads, the cosmetic threads running through here because I've said hide everything. So I'll turn everything back on again. But I'll go back to View and deactivate Sketches. And now we see this fake thread that it's cosmetically added in. It's also added in a dotted line. This is another symbol for a threaded hole or a tapped hole. And you notice that when I bring my cursor over that, I get that little symbol there at the end, which indicates that's a threaded hole. The hole it places through the part is the small diameter of the threads. So this would be the hole you would drill through first before cutting the threads into the body. So this takes care of all the holes at this end. Later on we'll find out what are some of the advantages of using this rather than just using a regular extruded cut. Now let's go to the flange area. Here we are actually going to have an M6 hole pass through, a bigger hole, and we want the hole to have a recess in it for the head of the screw to sit down into. We call this recess a counterbore. So here is the hole that passes through the flange, and this is the recessed area that we call a counterbore. This hole is going to be bigger than M6 so that the threads of the screw don't actually bite into it. This is what we call a clearance hole. And this portion of the clamp has the actual threaded holes. So what happens is the screw passes through this clearance hole, threads into this hole so that when we tighten the screw, these flanges will be pulled closer together in order to tighten the sleeve around the steering tube. So let's roll this back. We're going to pre-select on this face, Hole Wizard. Now we're going to go to this symbol here, which is for the counterbore. We want to tell it that we want a size to go through for an M6 screw. And the type of screw we are using is a socket head cap screw. That's important because a cap screw has a smaller diameter head than other types of screws. Solidworks has built into its database the knowledge of the appropriate size counterbore and through hole for each of these different types of screw sizes. We want this to go not through all, because if we do go through all, it's going to go through this flange also, which we don't want to do. So we want to change the end condition to up to surface. We just want this to go as far as this surface here. Under positions, we're going to add one more position down here. I hit my escape key again, turn on my sketches. I'm going to make sure that this center of this sketch point is centered on this hole. I can use either concentric to the hole or coincident to the center of the hole. And we'll do the same here. We'll make these two coincident. And when I hit the green check mark, it automatically has made for me the appropriate counterbore for an M6 screw and the appropriate diameter through hole without my having to go look that up in a chart. The last step finally is to put the threaded hole into this flange. So we will select this face here, Hole Wizard. And this time we're going to use a tapped hole again. This is the M6 screw that we want to add. I'm going to change this to M6 by 1. Go to positions. We're going to add another position here. Escape. Let's unhide. And make this and this coincident. The center of this, and it's hard to see, there's a center here in our sketch. Coincident, so our sketch is controlling, our layout sketch is controlling the locations of all these holes. I'm going to turn off my sketches, but not use hide all types because I want to be able to see the cosmetic threads here. So here is the M6 threads going through the flanges. Here's the counterbore that will be used later on for the screw heads that pass through here. Final steps are simple then. One is to add a fillet here and here. Another is a fillet that is just going to run around this perimeter. The fillet has a tendency to want to stop here, so you might have to select this edge and select over here and here to get the fillet to continue all around. a large blending fillet here. This would really be a weld between this part and this part. Then a few more fillets in the corners here of this slot. And we're also going to add some fillets to blend these screw bosses into the main arm. And do the same on the clamp. Blend these areas into this area. This fillet and this fillet cannot be done in the same operation because these are two separate bodies.